the open source based WebGIS servers could do a lot of things which the expensive proprietary softwares like ArcGIS server, Erdas had a server, I don't know if it exists anymore. So those proprietary softwares were exorbitantly expensive actually. So and there was glitches in those softwares as well. So this open source software, open source map server, GIS server, all these tools really saved this domain in this particular WebGIS applications in open source. And a lot of development happened and a lot of applications were developed on that. So why my intention today is to give you a bit of background on how this open source framework of WebGIS developed. Okay. Yeah, when we talk about WebGIS, it's all about spatial data infrastructure and management of data. Okay, you create a lot of data. For example, we created a lot of data. We created water productivity, water transportation. And when we talk to field officers or others, they are all concerned about, okay, you have data. What do we do? How do we access that? Yeah. So in that concept, the spatial data infrastructure, or SDI, came into picture long back, years back. So there is SDI for every country. There is European SDI. There is a NSDI, National Spatial Data Infrastructure for India. I don't know where it is. There is state level SDIs initiated. At least in Kerala, it was very strong some years back, but I don't follow it up anymore. So I don't know where it is now. And why we need SDIs? Because there's enormous amount of data, so we need good archiving and metadata. We should avoid redundancy. For example, ACIWRM will be creating a lot of data. If you put those data sets in well archived with well documented metadata, then there is less chance of redundant data being developed by some other agency. But yeah, but in India, it's we have a long way to go to reach there. So I know that in Bangalore, at least, there will be many organizations developing the same kind of data again and again. So all those, so the concept of WebGIS, okay, other than the fancy map which we see in a web browser, there is a underlying concept behind it. Why this movement started? It all started because we wanted to develop a spatial data infrastructure, and we wanted to use internet as a medium to disseminate this data, so that users, the end users, we are not talking about specialists, you're talking about decision makers, engineers, on a particular application, water, irrigation, biodiversity, anything, can access it without the knowledge of GIS and remote sensing. Okay, and then came all this fanciness into it. Yeah, I mean, how it can be. Yeah, so but at some point fanciness took over, and the real idea behind SDI got lost actually. It should be easily retrievable on requirement, interactive map against a list of maps. So it could be a single window to look for data over multiple sources. I think the idea of KWARIS is like that. So any data related to water in Karnataka, KWARIS should be a single window. And it also facilitates proper data dissemination through simple web services. And these web services can be accessible in QGIS, in desktop GIS, in web GIS. So one server, multiple clients. So that is the idea behind specification related web GIS. Reach to wider users and public. Now, what is happening actually? So the major problem is data islands. So we can consider IHE as one of this island, right? ATRI is one of the island. ACIWRM is one of the island. Another organization is another island. KSRAC is an island. So there are a lot of organizations sitting and developing data. There is no communication. There is no way communication in terms of data, the alignment with the data formats and things. So we have data with different standards, different quality, different formats we use with different coordinate reference system, different softwares. So we have, and it's up to each organization. We cannot really dictate that to make them use one single software or one single format. It's very difficult. So what we need is a term called interoperability. And interoperability is the key word behind spatial data infrastructure. Interoperability means in spite of developing data in different formats, different CRS, different softwares, they should be interoperable. They should be able to come together and make sense or do some analysis. So that is what is called interoperability. And that is something which you hear all the time when you search WebGIS. And I don't know how many of you have heard about OGC, Open Geospatial Consortium. Yeah, that's my next slide. Open Geospatial Consortium, OGC. It's a consortium of over 500 companies or institutes working in geospatial data. So years back, they decided that, okay, they develop a consortium and they sit and they create a lot of standards. Yeah, so if you go to their website, you will see PDF files with hundreds of pages explaining the standards which you should follow, which also became a bit tough for others to follow. But they did some good things with the basic specifications like WMS, which you might have heard about it, Web Map Service. So the idea was to develop standards which will facilitate which will facilitate the development of distributed spatial data infrastructure. So one or different nodes or different servers and data can be come together in a server and distributed again to different clients. What were the aims? The objectives were less local storage space. We don't have to store all our data in our machine, and also to avoid redundant data. The main goal of OGC is to make location information, the spatial information, fair, findable, accessible, interoperable, and reusable. How? Web services, accessible through simple web browsers, no need of GIS software, but if you want to access it through GIS software like QGIS, it should be also possible. Now, OGC this consortium developed a lot of specifications, and they are WMS, WFS, WCS. Those are the three major specifications: Web Map Service, Web Feature Service, Web Coverage Service. We can say Web Map Service is data type independent, because Web Map Service can be developed from vector and raster, but what it gives is a raster images as a result, as a service. WFS is actually sharing the vector data with the attributes through some standard specification. So if you convert your shapefile into WFS, and if A-Tree convert the shapefile into WFS, they both can talk to each other. They both can be merged and combined and do analysis together. So that is the idea. WCS it was a big thing that time, but yeah, didn't took off well. The most popular ones are WMS and WFS. There are many other. GML, you might have heard about it. It is like KML. It is a markup language which OGC came up with. SLD is one important thing, because SLD is the styling. So whatever you do in QGIS, in properties, symbology, that can be converted into an XML file, which is styled layer descriptor, which you have to do if you want to put your maps in GeoServer or Map Server, for example. They all use SLD. So they all use SLD means if you have a SLD for ETA map or a land cover map, you can use the same styled layer descriptor for Map Server or any other server which support SLD. There is web processing service is getting popular. Web processing service means server-based modules. For example, if you want to clip, if you want to buffer, some softwares has the WPS capability, which can be executed or which can be launched in a server where people can access it from server. So they don't have to install the software. They can access this module from this server. And there are many more. I mean, yeah, this session is not enough to go through it, but just to make you aware that, okay, there is such thing existing, and WMS, WFS, and all other things which you may have heard are coming from this particular consortium. And this is the link where you can go and you can read and see all this information. Everything is open. I will just go through two services which we generally use. WFS also we don't use much. We generally use Web Map service. Web Map service provides images of map data defined by a geographic or spatial component. It can provide point-based query functionality. It can composite map. So you can have the WMS from NRSC, National Remote Sensing Center, WMS from IHE if it is available, or WMS from ACIWRM. You can combine all of them and bring it into QGIS or any other WebGIS application. So that's the beauty of following this specification. Okay. For example, yesterday you made an application with the Google Earth Engine, right? And Google Earth Engine, you have a web browser, you see the data, but that is not a WMS. You cannot add that layer into QGIS or any other WebGIS application. It is Google's own format. It is in their hand. So that is the difference. So there are proprietary things. Of course, Google make you feel like you have everything, you have access to everything, but you have to remember that your data is with them. But the WMS is in such a way that your data, your original data, if it is proprietary, if you don't want to share, okay, you can put it in a server and serve it as a WMS. And in that way, you can also club it with other WMS services from different organizations. So one of the main or the major component of WMS is get map. So get capabilities means, what are the functionalities available in that server. Get map means, okay, get me the map. And get feature info means what exactly is that feature in that particular pixel. So that is what get feature info do. Or if it is a vector file in that polygon or a point or a line. So these are the three operations available with the WMS. So how does a get map service works? So if you put a get map request is basically a web URL. Yeah. So for example, this is coming from NASA, and till .gov, it is a server URL, server address, and it's saying, okay, please get me WMS, and with the version and the service, and the request is get map. We give a bounding box. We give the bounding box of the entire globe. If you want to give a CRS, you can give that and the layer name. And you get the map in your web browser. That's it. And if you access it in QGIS, you can zoom in, you can get feature info. So it works as any other maps. The only thing is you cannot do analysis with the WMS map. It is basically to show or disseminate. You can do analysis with the WFS and WCS, web coverage service, and web feature service. But yeah, people don't give data, so there are very less WFS and WCS services available. Yeah, so web feature service is feature level access to spatial data. So you actually have access to the data itself. Spatial and non-spatial query capability, download data, you can download the data, you can get it. And another very interesting part of the this WFS specification is WFS-T, which is transactional capability. That means you can create a WebGIS where you can digitize and store it in the database. So the client, the user can digitize in the WebGIS, and so it's a two-way transaction with the database or with the shapefile. So WFS-T was used or is used generally to develop this kind of, or if you want to create an application where users have to input some locations, then WFS-T is your friend. If you want to do it with a specification, of course, there are other ways of doing it. Okay, so this is what you need to know. Actually, I mean, this is exactly the architecture of a WebGIS which we develop usually using GeoServer or Map Server. You have a database, you have a map server which can handle spatial data. There's a web server which can handle the request, return the request in URLs and things like that. And you have a browser. That is the client. It can be through internet. You can also log the application to through an intranet only for your staff. So this part is generally client-side library. So in the database, it can be all the fancy databases like Oracle Spatial, SQL Server, PostgreSQL, MySQL, or our own favorite GeoTIFFs, shapefile, GeoPackage. So any kind of data can be your database. Map server there are many options. I already mentioned there is ArcGIS server, which was very popular. I think this is still very popular. Does Apollo, MapXtreme, but there are some open source servers which are called GeoServer, UMN Map Server, Degree, etc. Now this map server convert this data into this services, WMS and WFS services. And in this web server, it handles the request from this client. So these clients are usually libraries. The most popular ones are OpenLayers, MapBender, Leaflet. There are many. I don't say most popular, but there are these three are among the popular ones in open source client-side libraries. The application which you saw in the first day, which we developed, is based on MapBender, which comes with a lot of existing functionality. So we use that. OpenLayers is really popular. Yeah, so this is the architecture of a web mapping application. Now, I already mentioned this. Interoperability is very important. For example, if you have a data from one source and if you have a data from another department, if you don't have interoperability or if you don't have a WMS services, you cannot mix them or you cannot access them both together. So that is the caveat. So that's why we need interoperability. The SDIs usually work with, so you have a viewer client. So this slide shows how it can be done, this multi-map compositing using WMS services. This was done, actually, I developed this slide for a presentation in CGIAR because we had a lot of servers in different institutes under CGIAR, IMI. So we were proposing this. So a client can give a request to IMI server or one of the server, let us say it is NRSC server, and you get a map. And the client next to the request can be go to, for example, a server in ACIWRM, and we get that back this map. The beauty is if they both are WMS, can both be visualized together like this. There are two maps in your browser, in your QGIS, which is coming from two different servers sitting in different places. So that is the advantage. Many examples. Bhuvan is a very good example. I was really glad to see Bhuvan because Bhuvan really make use of OGC specifications, and it is made on open source as far as I know. I don't know if they have changed anything. Also, there is India Biodiversity Portal from A3. They really started from scratch. I remember giving to A3 a presentation long back in 2008. I did a presentation on OGC and things like we had some discussion on how we can make use of these specifications to develop India Biodiversity Portal. And now I see that portal, it's really grown a lot. I still hope that they still adhere to these specifications. IBIN, I don't know what's the status now, but there are several SDIs and web mapping applications. I don't know if this really exists. These are a bit old slides. Yeah, so the conclusion is that, okay, we have a key role in natural resource management. We need a proper archiving and data dissemination, and web mapping using OGC services is one option or the most ideal option, if I put it that way. I can also show you our app quickly. So we developed this app. So the data are, I did not implement any databases. It's basically shapefile and GeoTIFFs, but all converted into WMS. So it's based on WMS services. We use GeoServer, and the client is based on MapBender. So you can also check MapBender. I like MapBender. So this is a client library, open source. It's in German. It's from Germany, and they are really good. I have provided this land use of NRSC map here. the precipitation, some NDVI maps, and I will be adding all the maps here, hopefully by tomorrow. For example, ETA is also there. So one option is if you want to check a distribution canal network, let's say for I don't know, somewhere here. So for each layer, there is a zoom function. So you can open that layer and you can click on these 3 lines here, this icon, and there is a zoom function and it will zoom to that particular area. So each layer has a zoom function. So you can use that function to navigate to different distribution network and see the results also. There are zoom in, zoom out function here. Okay, and okay, it's the extent is too big, but you can always come back to our extent by zoom in. There is a feature info button. If you click on feature info, okay, for canal network there's no feature, but for ETA, so there is accordions here. You can see each layer, whatever layers are open, you can see all the information there. You can also export this image into PNG or JPEG if you want to showcase it quickly to any of your meetings and stuff. You can see the legend here. You can also measure the distance here. It's like any other GIS software. If you want to measure this canal length, and it will show you it is 1.23 kilometer. Okay. Yeah. Also, the base map is Sentinel map. There is a private company called EOX WMS. So if you check, and they provide WMS services of Sentinel tiles. I really like it, and I generally use that WMS services in our applications. I can put this link here. So that is what we use as a background in this. So this is Sentinel image, I think, of 2019. For each year, they give a WMS service of Sentinel-2 tile, which is really good. You also have the option of OpenStreetMap. You can if you want to see the places and stuff, OpenStreetMap is there, or you can put Sentinel-2. And another good feature, in my opinion, is also if you want to see what is behind, you can use, there is a slider here, transparency slider. You can make it transparent and see what is actually behind it. So that option is also available with this app. If you might observe a couple of things, for example, if I put NLBC boundary, if you zoom 2 levels, you start seeing the name of the command area. So we have given a scale dependent labeling here, and in the scale SLD file. So those are all specifications. And also, if you click on field points, you will not see field points in the beginning. You have to zoom in, and the field points start appearing only after a particular zoom point. So the field points are also added. You won't be able to download this data because it's WMS. You can only see and see the values and explore this. So so this is a very good example of what I just showed. This is exactly a WebGIS application developed over OGC specifications.